Okay, let's dive right in. We're going to explore this kind of hidden map that AI uses to make sense of our language. And here's the twist. It's not about reading words like we do. Nope. It's all about plotting their location in this massive, invisible universe of meaning.
So, first things first, let's just blow up a really common idea about how AI works. Most of us have this picture in our heads. But what if I told you that picture is, well, completely wrong? So, on the left, you've got what most people think, right? That an AI sees a word like happy and just looks up its dictionary definition. Makes sense. But the reality, over on the right, is so much cooler and honestly a little weird. It's all geometric. See, the AI doesn't have a clue what happy means in the human sense. It only knows where happy is, where it's located in relation to every single other word. For AI, it's literally all about location, location, location. Okay, so if it's not using definitions, then how on earth does an AI build this map of meaning? Well, believe it or not, it all boils down to this really simple but super powerful idea from way back, like over half a century ago. And here it is. This one quote from a linguist, J.R. Firth, is the absolute key to everything. You shall know a word by the company it keeps. Think about that. An AI learns about a word not from a dictionary, but by looking at all the other words that hang out with it, its company, across billions and billions of sentences. Then it takes that giant, messy web of friendships and turns it all into simple coordinates on a map. So the big idea, the mental model we're going to stick with through this whole thing is this. Language is just geometry. That's it. A word's meaning isn't some abstract concept locked inside the word no. It's just its position, its location relative to all the other words on this giant cosmic star map. All right, let's make this super concrete. Just imagine for a second that all words are stars. Words like happy and joyful, well, they're going to be stars shining right next to each other, kind of forming this little constellation of good vibes. But the star for happy is going to be light years away from, say, the star for calculator. They're not even in the same galaxy. So for an AI, a word's meaning, it's really just the address of that star on the map. Okay, theory is cool, but let's get our hands dirty. How does an AI actually plot a word on this map? We're going to build a super simple, two-dimensional version for the word happy right now. The process is actually way simpler than you might think. First, the AI just does a bunch of counting. It counts how many times happy shows up near our two context words, smile and birthday. Then it just draws a simple graph, with an X and Y axis, one for smile, one for birthday. After that, it's as easy as plotting a point for happy based on those counts. And then it does the exact same thing for another word, like sad, so we can see where they both land. Okay, now this is what the AI actually sees. It's not seeing words, it's seeing raw data, just numbers in a table. This little table has a fancy name, a co-occurrence matrix, but all it is really is a list of the counts. This is the raw material, the clay, that has all the information the AI needs to build its amazing geometric map. And here's the magic trick. This is where it all comes together. Those boring numbers from the table, they become specific locations on the graph. Boom. Happy gets plotted at coordinate 10,8, while sad is way, way down at 1,2. And this is the absolute key, you guys. The physical distance between those two dots on this map is the difference in their meaning to the AI. That's it. Okay, let's pause here because we've just hit the part where almost everyone gets tripped up. And this is absolutely crucial to get right if you really want to understand how these AI systems think. So here it is, the big mistake to avoid. That number 10 on the smile axis, it doesn't mean very happy. It doesn't mean anything at all on its own. It's just a location. Meaning only comes from a word's position relative to all the other words on the map. It's all about relationships, not absolute values. So let's just stop and think about this for a second. What if we added a third axis, a third dimension for the word ice cream? What do you think would happen? Well, happy probably shows up near ice cream pretty often, right? But sad, probably not so much. So that new axis, that new dimension would actually change all the relationships and probably push happy and sad even further apart on the map. All right, so now that you've got this core idea, this intuition of the star map, it's time for the big reveal. Let's put the formal technical name on this whole concept. It's called the Vector Space Model, or VSM for short. I know, it sounds super technical and kind of scary, but honestly, it's just a fancy name for the simple idea we've been talking about, representing words as coordinates in a space.
And this is it. This is how computers use plain old geometry and math to figure out something that feels so uniquely human. Meaning.
And that word vector, don't let it intimidate you. A vector is just the list of coordinates. It's the address for a word in this space. So for a little map, the vector for happy was just 10,8. That's it. Simple as that. Okay, let's wrap this up and pull it all together. Here are the key takeaways, the main things you need to remember so you can start using this language as geometry model yourself. Okay, 3 things to lock into your brain. First, words are just addresses. Meaning is location. Simple. Second, we used a little 2D map, but a real AI, like the ones you use every day, they're using maps with thousands of dimensions. That's how they get all that nuance. And third, when you ask an AI to find something related to something else, all it's doing, literally, is looking for the closest neighbors on this giant invisible star map. And to finish up, I want to leave you with a little puzzle, a question that, with this new mental map, you can totally answer. Why does an AI get so confused by a word with 2 meanings, like bank? Well, think about it. The AI is trying to plot a single star for bank, but that star is being pulled in 2 different directions at once. It's trying to be in the river constellation and in the money constellation at the same time. The math just breaks down because it can't be in 2 places at once.